Hello, everyone. Welcome to Detroit. Welcome to KubeCon 2022. Welcome to this Istio session. My name is Tom Lee, Senior Software Engineer at IBM and a Istio maintainer. Today, we will focus on Istio multi-primary, multi-cluster, and external control plane deployment in IBM Cloud. Before we dive into the two most complex deployment models, I will mention IBM Managed Istio and talk about Istio deploy models in general. IKS provides every cluster a list of add-ons. Istio is one of these add-ons. After you have your cluster created, if you go to your cluster overview, you can easily find the Istio add-on. By simply click on Install button, you can have Istio installed onto your cluster with a public, fully qualified domain name, which has two public IP addresses associated with and are ready for your applications. This is a great feature compared to other clouds, which you may have to separately request, most likely have to pay for it. The add-on panel shows the current state of Istio and allows you to easily remove Istio if you no longer need it. IKS Managed Istio uses a canned configuration for Istio control plane. You can use other tools like Istio Cuddle to further configure your Istio control plane. Istio workloads can be managed like any other Kubernetes resources by kubectl or tools like Helm. If you'd like to have more information on IBM Managed Istio, please participate another great session named Getting Started with Istio using IBM's Managed Istio. Users can deploy Istio many ways. When configuring a production deployment of Istio, you need to answer a number of questions. Will the mesh be confined to a single cluster or distributed across multiple clusters? Will all the services be located in a single fully connected network? Or will gateways be required to connect services across multiple networks? Is there a single control plane potentially shared across clusters? Or are there multiple control planes deployed to ensure high availability? Are all clusters going to be connected into a single multi-cluster service mesh, or will they be federated into multiple mesh deployment? For cloud providers, it is probably important to have control plane live in a cluster which cloud providers have full control and allow users have workloads running in their own clusters, which customers have full control but do not have to manage Istio control planes. This deployment model provides great benefit for both cloud providers and customers. When your workload do not need to cross many clusters, or the size of your deployment is relatively small, you can choose a all-in-one model, which has both Istio and your workload running just in one cluster. This is the simplest Istio deployment model. It is relatively easy to set up. When you have multiple clusters and they all are on the same network, you can choose to have one control plane running in a cluster and a workload running in other clusters without cross-network gateway. When you have multiple clusters running on different networks, that is, workload cannot reach each other directly, then users will need to create cross-network gateways to help the workload to reach each other. This will be a typical primary remote deployment model on multiple networks. Similarly, user can have multiple control planes installed in multiple clusters, even when these clusters are on the same network. This is a multi-primary deployment which provides high availability from Istio control planes perspective. Multiple primary on multiple networks deployment model allow users have Istio HA across multiple networks. External control plane, split control plane, and workload. Allow workloads and Istio control plane clear separation divides cloud providers' responsibility from users' responsibility, so that the providers focus more on Istio control planes and the users focus more on their workload. And Istio artifacts such as virtual services, destination rules, multiple primary on multiple networks, and external control plane deployment models are the most complex among all different deployment models. We will focus on these two and discuss how we can do both in IBM Cloud. Assume that you have done your research and decided to use multi-primary and the multi-networks deployment model for your production in IKS. Here are the steps that you can take to get things going. First, let's say we create 2 IKS clusters. Then you need to create a load balancer in each of the cluster which will be used by Istio and workload for traffic go in and out of the cluster. Install Istio control plane and the ingress gateway. Customize ingress gateway with additional ports for traffic in and out of the cluster. Create Istio east-west gateway so that the workload traffic can cross clusters. Create certificates for each cluster and add that certificate to the other cluster so that multiple control planes can communicate. After that, we can verify the control planes in both cluster, then deploy some test workload and verify. Here we create, we have 2 clusters already created. One is called Tone Cluster 1, the other called Tone Cluster 2. So we're going to use those 2 clusters to demonstrate how we can do multi-primary on multiple networks. Obviously, these 2 clusters will have to be connected to use gateways. So the first thing we have to do is to create a load balancer. As I mentioned earlier, when you create a load balancer, IBM will provide you a public DNS entry. So this is a fully qualified domain name that it can use on the internet. So this is important because if you do not create this and create it while you install Istio control plan or pilot, I still will not be able to resolve the domain name. So you want to create this first and wait until this load balancer entry created and can be DNS resolved. Then you can move on. So here we just want to see, we add this 15443 port so that you can use for the workload traffic. After that, we will install Istio control plane in both clusters. This is an example of the Istio manifest that you can use to install the control plane into each cluster. And you will need to replace, once you have the control plane installed in both clusters, you will need to create this gateway to allow traffic to go in between them. After that, you want to create the certificate for one cluster and place into the other cluster. So this way, the one cluster control plane will treat the other cluster control plane as a remote cluster. So this step is very important. Doing this will allow the control plane from each cluster to be aware of the other control plane. So this is how we set up multiple primaries. You may think this takes multiple steps, but you can use this script that I created. Just run this script if you have 2 clusters, and just run this script. You should be able to set this up within just a few minutes. Let's now check things in the Istio system namespace and make sure everything works as expected. You can see we have 2 clusters, and let's set up the context to an environment variable so our command wouldn't be very long. Okay, now you can see we have this Ingress Gateway service and ICOD service. And Ingress Gateway actually is a load balancer type. So we can see the public domain name and all the familiar ports like 15021, 15012, 17, and 15443. Okay, let's also look at the PUTs and then make sure that Istio PUTs also work fine. Yep, so here they are, and everyone is running and no restarts. That's great. So now let's switch to a different terminal and check the class 2. Okay, we do the same thing, but the context now is the class 2. So let's do this, check things in the namespace, get services. Okay, similar, but this is in class 2, and we can also look at the pods. All right, same thing, they're also running fine. Now deploy the Hello World app. We run on cluster 1 and we 2 on cluster 2 to see how the load distributed across 2 clusters. We create a virtual service with the host, and then we create the service entry that indicate some of the load should be happening on the other cluster. Now let's verify our applications behave as what we expected. So first, we're gonna check the things in the cluster number 1. So we have the application deployed into the sample namespace. Now you can say we actually have Hello World and a Slip workload running without any issue. And we can also see the endpoints from the Sleep pod perspective. Okay, so we're going to use just Istio cuddle and look at the sample, use the Sleep pod, and see the endpoint for the Hello World app. Okay, you can see that we actually have some local app, and also we have the external endpoints that run in different cluster. Okay, we can check the same thing on a different cluster. Okay, so this is in cluster number 2, and you can also see the endpoints. Okay, so the endpoints, if you look at the IP closely, these IPs are different. Okay, so this seems work correctly, no issue at all. Now we wanted to actually hit an endpoint and see if the request actually distributed as we expected. Okay, so I have this little bash script, basically just loop 10 times and send the curl request to the passed in endpoint with this port and the path. So now we simply needed to call this with the endpoints from each load balancer, which we can see here. Okay, so we just pass in this domain name. Now we can see that though we just hit one endpoint, like a domain name here, use the public domain name, we are hitting both service workload, right? V1 and V2. Can deploy external control plane in IKS. As before, we create 2 IKS clusters, then we create a load balancer in the external cluster where Istio control plane will run. Then we install Istio artifacts such Istio mutating webhooks in the config cluster and make sure the webhook using the service is running in external cluster. Then we create a service account in cluster external and a certificate for cluster tone and add the certificate as secret to cluster external using the service account. Next, we deploy control plane to external cluster and create an ingress gateway in config and verify Istio control plane and artifacts from both clusters and then create a workload. Then we test and verify. As you see before, we use 2 clusters, one called external, one called config. Then first thing we do is create this load balancer on the external cluster where Istio control plane will run. Then we set up the namespace and label the namespace on config cluster and mark it network 2. And then we also use this external profile, install Istio artifacts in the config cluster, and just make sure that in the ejection URL and the validation URL, you have to use the other cluster's load balancer address so that the config cluster knows how to access control plane. Now, in the external control plane, we create a service account and create the remote secret for the cluster config and place that in the external cluster. Here are the code that you can use. After that, we create Istio control plane in cluster external. And again, you can see that we use the profile empty. So we just want to install the base Istio component and the pilot. We don't install anything else. Now we also create this Istio ingress gateway in config cluster. So if you want to do all these things very quickly, you can use the script that I created. Let's verify and see if everything goes as we expected. Verify our external control plane set up correctly. First, we set up this environment variable, which point to the external point to a cluster which we use for the external control plane. Then we can look at the Istio artifacts in this cluster. Okay, so we have external control plane installed in external Istio namespace. Let's look at them. You can see that we have Istio pod running. Then we have load balancer service running. This is necessary for the config cluster to access Istio. Right? You can see this is just the Istio ports. No, ports for a workload. Okay. Then we look at the config cluster. See what's in this config cluster. So here we see we have an ingress controller pod. Then we have also a load balancer. This is for the workload. So we have this public domain name available so that we can hit our workload using this name and the open port. Okay, so if we look at the webhooks, we can see that we have this Istio webhook right here for sidecar and the revision, and we should be able to just look at the actual configuration for the webhook. One thing to check is that the webhook, in this case, will have to have the CA bundle actually changed, configured by the external control plane. So this certificate actually is coming from the external control plane. So this is really important. If this is not happening or this CA bundle is missing, that means this cluster has not been set up correctly. And also the failure policy should have been changed to fail, and the generation should have been increased. If I grep for a generation, see this generation is now 1. So that means this webhook has been modified. After we deploy Hello World app v1 and v2 in configure cluster, we wanted to set up the gateway and destination rules and the virtual service so that we can test the request coming outside the cluster can hit the gateway and distribute the request to different workload. Let's verify our application running as expected. We set up this environment variable point to this config cluster. Then we check what is running in the sample namespace. You can see that we have 2 versions of Hello World running. All right. Then we have the services, and then we have the deployment. If we check our gateways, destination rules, virtual services, you can see we have those set up as well. All right, so everything is running, and let's also get this endpoint. Okay, we're gonna use this public domain name and try to hit the service and see what we get. Here I have this also the little script which basically hit the endpoint with the path hello and the loops 10 times. So we can send the request from my laptop. We use the public IP address or domain name. You can see we get the response back from both workload v1 and v2. Now you probably noticed that during this demonstration, we have only used HTTP, not HTTPS. This was done on purpose to reduce the number of the steps involved during the configuration. In almost every production deployment, you would need to secure your application using TLS. To learn more about that, please head over to Eric's presentation on secure your cluster in IKS with Istio. That's all the material I have. Thank you very much. Thank you for coming. I take any question.